Okay, in our first example of evaluating a definite integral now using U substitution. So the beginning of this is going to be exactly like what we did a day ago. We're going to assign a value of U. And keeping in mind, we need du to help us. We need du to pick up whatever we don't have with u. So u in this case, we can make tan of x. And then du, we know is the derivative of the tangent, secant squared x dx. Next, let's make our substitution. The integral, u takes the place of tangent, and du, secant squared x dx. Here's where the change occurs. Our limit values that we see for the initial definite integral, 0 and pi thirds, those are values in terms of x. What I'm going to do next is make these values of u. So going back to what I initially signed u for, I'm going to first plug in lower limit. So tangent of 0, work that out. We know tangent sine over cosine, so 0 over 1. So this new limit value for in terms of u is still staying at 0. Then we do the next thing, upper limit. Plug in pi thirds. U equals tan of pi thirds. Pi thirds, we know, 60-degree angle. Tangent, radical 3. Now what we've created is we have our definite integral in terms of u completely. Limits in terms of u, variables all in terms of u. Next we'll find the antiderivative. So u, add 1 to the exponent, u squared. There's my half from 0 to radical 3. Next, we'll plug in our limits. So we have 1/2 times radical 3 squared minus 1/2 0 squared. Now we can see this second half is going to go to 0, so the first half, radical 3 squared, is 3 times 1/2, gives me 3 over 2. So to wrap this up, what we've done here is we've saved a little bit of time. It is perfectly okay for us to take what we have here after we integrate in terms of u and put it back in terms of x. If you choose to do that, though, then our limits shouldn't be changed. Changing the limits, we actually save a step and it goes a little bit quicker.